Hi everyone! We have all the pieces now and we just need to put them together and officially define the derivative. So we're going to go back to this exact same thing that we've been working on. We have this imaginary calculus curve. We've defined a point that we're very interested in, A, and then we define a second point based entirely on how far away from the first point it is. So that's what H is. It's how far apart the 2 points are. If we want the slope of a secant line, we calculate f of A plus H minus f of A all over A plus H minus A, which just gives us H, because again, H is the distance between our point. It's our run. And I would point out that H doesn't have to be positive. If we allow H to be negative, that will mean we have a point on the left-hand side of A as well, so it would capture both of those possibilities. So the only thing we need to do now is figure out how do we get that to turn into the slope of a tangent line. So the tangent line looks something like this. And what we've been working our way up to is the idea that if we let that second point move in closer and closer and closer, the secant line is going to start to look more and more like that tangent line. So what we need to do is to let the H get really, really small, or H goes to 0. And the way that we write that is by taking the limit as H goes to 0 of our difference quotient. And ta-da, we have the derivative. That is called the derivative of f at x equals a. The shorthand for that is f prime of a, so f prime of a equals, and that is the definition of the derivative. Derivative means the exact same thing as slope of tangent line. It means the exact same thing as instantaneous rate of change. And if your original function is a position function, then f prime will give instantaneous velocity. So instantaneous velocity at x equals a is exactly the same thing as f prime of a. Again, assuming that your f is a position function. If we're doing this and we find that the limit does not exist, then we get to say that f is not differentiable. So keep that little piece of vocab in the back of your mind. We can say f is not differentiable, there is no derivative, there is no tangent line. And we'll get into this a little bit more, but that will happen if there is a sharp corner. That will happen if there's any kind of discontinuity. That will happen if there's infinite oscillation. I feel like I'm missing one there. That will happen if the tangent line is vertical. We will get, it does not exist there for our limit. So those are all possibilities that would mean that the derivative is not defined or the function is not differentiable. So we're there, yay, and the only thing this is going to add to our work when we're calculating derivatives algebraically is the limit step. We have already done all of that difference quotient work, so this is only going to add a tiny piece onto what we were doing before 1.2.